Okay, so we're going to keep graphing, and we're going to look at some special cases. So the special cases, first one is, what if there is no number with the y? So if there is no number with the y, that means that our original equation right here is supposed to look like y minus 0 equals 4 times x minus 1. So it's indicating that there really is no number with that y. So when we're looking at that starting point, I look here at my x, and if it says -1, that means I have +1. There's no number with the y, which means it's 0. So this is a starting point of 1, 0, and then we have a slope of 4. So 4 over 1, which means I go up 4, right 1. So from here up, 1, 2, 3, 4, right 1. 1, 2, 3, 4, right 1. Or down 1, 2, 3, 4, left 1. Down 1, 2, 3, 4, left 1. And so this would give us our line. So just a special case to be aware of. So on our next one, let's look at our x. It starts at -8, so it means it's a +8. There's no number with y, which means 0. So I'm starting at 8, 0. And then I have a slope of -3 over 4, which means I'm going to go down 3 and right 4. So when I'm looking at this point, all of a sudden now I can go down 1, 2, 3, but I can't go right 1, 2, 3, 4. I kind of run out of room. I'm off the graph. So this is where it helps to really work backwards. So instead of down 3, right 4, I can now go up 3, 1, 2, 3, and then left 1, 2, 3, 4. And then up 1, 2, 3, left 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. And that'll give us our line. Okay, so now what if there is no number with the x? So when there is no number with the x, that means again that x value is 0 for our point. So when I'm looking here, this is really the same thing as y minus 6 equals 2 parentheses x minus 0. Now since x minus 0 is really x, this inside would simplify to x, and then that just leaves us with that 2 times x on that one side. So when there's no number, but you should know now that really there is no number with that x. So when I'm looking at my point, my x value is 0, and then I look at the y to find out that that's -6, so I start at +6. And then my slope is the number right in front of the x again, just like usual, so 2 over 1, which means I'm going to go up 2, right 1, up 2, right 1, or backwards, down 2, left 1, down 2, left 1, down 2, left 1, so on and so forth. And there's our line. So on our next one, there is no number with the x, so that means my x value starting point is 0. And then I have a +1, which means for my y it's going to be -1. So I'm going to start at 0, -1. And then my slope is 1/4. So I'm going to go up 1, right 4. Or backwards, down 1, left 4. And that'll give me my line. Now, these situations are actually way more common than you would think. In fact, we used to only graph in this type of situation. And so now we're starting to see, well, when I have a 0 here, that just turns into mx. Well, then I can move over this y. And then all of a sudden I've got this form, which most of you probably recognize from previous math experience, y equals mx plus b. So those two cases that we had there are a special form of y equals mx plus b, where m is the slope, like always, and b is our y-intercept. So what happens is, let's look back at this. You see how this crossed at 6? Well, if I would have moved this 6 over, that would have been my y-intercept, or where it crosses my y-axis. And if I look over here, it crosses at -1. So if I was to take this 1 and move it to the other side, all of a sudden it gives me where it crosses my y-axis at -1. And so now we use this idea of this y-intercept, or where it starts on the y-axis, as where we begin to graph. So when I'm looking now, I'm all of a sudden going to begin on this y-axis. So here, I'm going to begin at -7 on the y-axis. And then I'm going to go ahead and use that slope. So my slope is 3, or 3 over 1, which means from this point, -7, I'm going to go up 3, 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. And it's really not all that different graphing the way we have been graphing. But it's been a very big favorite of graphing for a long, long time. Now there are drawbacks to it, which is why as mathematicians, as we move up into higher level math, we don't always use this. Because most of our graphs that we're seeing here go from 10 to -10. Well, what happens if it crosses at -23? If it crosses at -23, we're not going to be able to graph it on here. We're going to have to make our own graph. And then we have to go all the way down to -23 on a graph that we make, which is not as cool. And so that's where point slope formula is really nice, is because we can take any point anywhere that may fit on our graph and then use the slope to help us get more points. But we need to be familiar with it all, because if they're giving it to us in a certain form, we have to know how to graph it in both forms. So let's look at our next one. Our y-intercept is -3, so I'm going to go to the y-axis at -3, and then I'm going to use that slope. So this slope is 2, so 2 over 1, which means I'm going to go up 2, right 1. Now, other reasons why we may not like using point slope formula, slope intercept form. What happens if my y-intercept is a fraction or a decimal? It makes it really hard to graph an accurate line if I don't even know where 2.3 is on that y-axis. I'm just totally estimating. So point slope form will give us a point anywhere, so that way we don't have to deal with that fraction on the y-axis. So again, you have to be familiar with both, but there's a reason why we keep hitting really hard with point slope, because as you get older, it just makes it so much easier. Okay, next one, our y-intercept. We're going to begin at +4 on the y-axis, and then our slope is -2 over 5. So I'm going to go down 2, right 5. Down 2, right 5. Or backwards, up 2, left 5. Up 2, left 5. Okay, so on our next one, our y-intercept is +1. So on the y-axis to +1, I begin there. Then I'm going to use that slope 2/3. And slope, it begins with an M because not only is it mountain slope, which really kind of gives you a visual picture of steepness, but also tells you how you move on your graph. So from here, I'm going to move up 2, right 1, 2, 3. Up 2, right 1, 2, 3. Up 2, right 1, 2, 3. Or backwards, down 2, left 3. Down 2, left 3. Down 2, left 3. And again, the line is an accurate representation of all solutions to that equation. We want our answers to be as accurate as possible, so we want our line to be as accurate as possible. Okay, next one. We have a y-intercept of -3. So I'm going to go to the y-axis at -3. And then I have a slope of 0, which is a fraction of 0 over 1. So I go up 0, right 1, up 0, right 1. Gives me an idea that it's straight across. So I can draw my line. Okay, our next tricky one. Y equals 4. But there's kind of a problem. There's no x. So I'm going to rewrite it. So there is an x. Y equals, there's no x. And then I have a +4. So that way it's in a form that I can recognize and I don't make a mistake. This tells me that my y-intercept is +4. and then my slope is 0 over 1. And I know it's 0 because there was no x. When there's no x, my slope is 0. So I'm going to go up 0, right 1, up 0, right 1, which tells me and reminds me that a slope of 0 is a flat, straight across line. Okay, so what happens if it's not written in point slope? It's not written in slope intercept, but it's written in standard form, which looks like this. Some number times x plus some number times y equals some number. And we've talked about this. We saw this when we were talking about slope. We saw this in chapter 1, and it just keeps coming back because it's probably the most complicated part to graphing, because you have to make sure you have those algebra rules right. You're not combining like terms, and it really tells us how strong your math skills are. So what we're going to do is we're going to try and write this in slope intercept form. We want this to look like y equals mx plus b. That's what we want. And that's what we practiced in chapter 1. That's what we practiced in section 4.3, I think it was. And so we're seeing this again. So I want to get y by itself, so I'm going to move the x. Since that's a positive 4x, I'm going to minus 4x on both sides. Keeping in mind that even though I'm minusing 4x on both sides, these do not combine because the 35 does not have an x, so they're not like terms. So now I have negative 5y equals negative 4x plus 35, and it's plus 35 because that 35 is positive. And now I divide everything by the number in front of y. So I divide by negative 5. We always save dividing for the end, because that way we don't really have to deal with the fractions that are left behind. So the 5's cancel, the negatives cancel, and this gives me y equals, the negatives cancel here, so I have 4 over 5 x, and then 35 divided by negative 5 gives me negative 7. So now all of a sudden I have a y-intercept value of negative 7 and a slope of 4/5, and it allows me to graph that line. So let's practice this a little bit more. Okay, so graph 2/3 x, or no, 2x plus 3y equals 6. So I'm going to start by moving that x, minus 2x from both sides. So now I have 3y equals negative 2x plus 6. Now I got to get rid of the 3, so I divide everything by 3. So now I have y equals negative 2/3 x plus, and then 6 divided by 3 gives me 2. So my y-intercept is 2. So I go to the y-axis at 2. And then my slope is negative 2 over 3, which means I go down 2, right 3. Down 2, right 3. Down 2, right 3. Up 2, left 3. Up 2, left 3. And up 2, left 3. And that gives us our line. Okay, let's look at one more. 5x minus 3y equals 12. So I move my 5x to the other side. Now when I move that 5x, I'm left with a minus 3y. I don't want to forget that minus because it'll throw off everything for my line. So now I have a minus 5x, I have a positive 12. Now I divide everything by negative 3. So the 3's cancel, the negatives cancel. I now have y equals, the negatives cancel here, so it's 5/3 x. 12 divided by negative 3 gives me negative 4. So my y-intercept is negative 4. So I'm going to go down negative 4. And then I have a slope of 5/3. So I'm going to go up 5, right 3. Up 5, right 1, 2, 3. Up 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, oh, run out of room. Down 1, 2, 3, 4, 5. 1, 2, 3. And that gives us our line. Now there's some key parts to these graphs that I want to point out to you. There are things called our y-intercept. That's where it crosses our y-axis. And there are some things called the x-intercept. And standard form is really good for identifying most of the time x and y-intercept. Usually it goes through an x and y-intercept, but not always, as we can tell with this one. It crosses right here. And so a lot of times we may ask you, what is the y-intercept? Where does it intersect the y-axis? What's the x-intercept? Where does it intersect the x-axis? And we're looking for key parts of these graphs, because as we move into different types of graphs and we move into contextual problems, these are going to be really important to us.